Welcome to Module 10 on Greatest Common Factor. Right now, make sure you have your notebook out and ready to take your notes. You don't want to have to re-watch all these videos every time you learn a new topic or you need to refer back to something. So make sure that you're writing your notes down and saving those in your notebook, and that way you can use them on your quizzes. The agenda for Module 10 is on finding the greatest common factor of polynomials. So we're going to start by finding the greatest common factor, and then we're going to dive just a little bit into factoring by grouping today. We want to start by being able to find the greatest common factor, which you're going to see me abbreviate from now on as the GCF. But right now, I want you to find a new topic in your notebook and write down finding the greatest common factor, and in parentheses put GCF. To find your GCF, you're looking for the largest number and largest number of variables that each term can be divided by. So I always start by looking at my numbers. I want the greatest common factor of 20 and 15. So I think about the things that 20 and 15 can be divided by. If you know right away, great. Some of you do not though, and will need to make a T-chart. I start with 1 times what makes 20? Well, 1 times 20. And then I try 2. 2 times what makes 20? 2 times 10. And then I try 3, but 3 doesn't multiply to make 20, but 4 does. And I know I'm done because I've now reached 5. So if I went up, I would just be going up the other side. 6 would not work, 7 would not work, 8 would not work, 9 would not work, but 10 would work. But we've already got those. So now let's do 15. 1 and 15. 2 does not work. 3 does. 3 times 5. 4 does not work, and we've already got 5, so we're done. We're looking for the largest number that 15 and 20 can both be divided by, and that's 5. These don't share any letters in common at all, so the largest number that 20b squared and 15a to the third can be divided by is just 5. For one like this, when I look at the factors of 5, it is only 1 and 5. There is nothing else. 9 is 1 and 9 and 3 and 3. The largest number they both have in common is 1. It is important that you recognize that 1 is a greatest common factor. They don't share any variables in common, so for this answer, it would just be 1. Now, let's do some that are a little more difficult. If you don't know your factors of 12 and 15, you'll make your T-chart, but I'm not going to do that every time. The largest number that 12 and 15 can both be divided by is 3. What I want to think about now are my W's. There are 2 W's in the first one and 3 W's in the second one. The largest amount that I could take out of both is 2, so the GCF is 3W squared. You pause the video and try this one on your own. The largest number that 10 and 8 can both be divided by is 2. And then if I write these out, b squared is b times b, b to the fourth is b times b times b times b. The largest number I can take out of both is 2, so that would be 2b squared. The exponent is how many you can take out of both. All right, how about 16 and 28? Well, 16 and 28 can both be divided by 2, but they can also be divided by 4. So the greatest common factor is 4, but now let's look at our letters. Let's look at our V's. They have to have the same number able to be taken out of both. I can't take 8 out of v to the third. I can only take 3, so it would be v to the third is the highest number I could take out of both. For the x's, the highest number I can take out of both is x squared, and there are no u's in this one, so that's not in common, so I just stop there. You pause the video and try this one on your own. The GCF has to be 4 because 24 and 20 are both divisible by 4. If I look at my V's, the largest number I can take out of both, there's 4 here and 1 here, so the largest amount is b to the 1. If I look at the W's, there's 6 here and 7 here, so the largest number I can take out of both is 6, and they don't share the U's, so I'm done here. Now, we're going to need that skill to actually factor. If I want to factor a binomial, I want to find the GCF of the two terms, and essentially I'm doing the distributive property in reverse. So first, let's look at 12 and 16. 12 and 16 are both divisible by 4. So the GCF is 4. This one has 1m, this one has 2m's. The largest amount I can take out of both is 4m. So now I want to actually take this out. This is what we were doing before. I want to divide both terms by 4m to the 1. Well, 12m to the 1 divided by 4m to the 1, if we write that off to the side, 12 divided by 4 is 3, m to the 1 divided by n to the 1 cancel, so you're just left with 3 for that term. For this one, 16 divided by 4 is 4, so we're doing 16m squared divided by 4m to the 1. 16 divided by 4 is 4. To divide with exponents, we subtract, so that's just m to the 1. This is your solution right here, but just to show you what it is that we're doing, we're using the reverse distributive property. If I multiply this, this gives me 12m to the 1 plus 4 times 4 is 16, m to the 1 times m to the 1 is m squared. So that becomes 12m to the 1 plus 16m squared, and that would be the reverse distributive property. But that's not my solution. This is my solution. You pause the video and try this one on your own. All right, you should have recognized that your GCF, the largest number that 10 and 4 are both divisible by is 2, and the largest number of a's that you can take out of both is just 1. This one has 2, but this one just has 1. So my GCF is 2. So we're using reverse distributive property to divide out a 2a from each term. 10 divided by 2 is 5. A squared divided by a is a to the 1, because we subtract with exponents when we divide. 4 divided by 2 is 2, and a to the 1 divided by a to the 1 gives me a to the 0, which is just 1. They cancel out. This is your solution right here, but to show you what we're doing in reverse, if I were to reverse this, 2 times 5 is 10, a to the 1 times a to the 1 is a squared, 2 times 2 is 4, times a to the 1 is just a to the 1, which is what we started with. Now, let's take it a step forward. So I want you to start a new topic and call it factoring out a common binomial. We want to treat the binomial as if it were a GCF. So what I have here are two things being multiplied, 3x squared times x plus 5, and negative 7 times x plus 5. In both cases, here we have a factor of x plus 5, here we have a factor of x plus 5, so our GCF is equal to x plus 5. So remember how before we were dividing out x plus 5 from both terms? So we're going to put that out in front, but it needs to be in its own set of parentheses. And then just think about what's left. If we take out the x plus 5, we're left with 3x squared minus 7. And that's it. You pause the video and try this one on your own. Start with your GCF, and then fill in your blanks here. You should have recognized that your GCF is y minus 6 because both of these have a GCF of y minus 6. What you're left with is 8y here, and then y minus 6 divided by y minus 6 gives me plus 1. There's always going to be an invisible 1 here if you don't see anything. All right, so factoring. We factor so that we can do other things. This is like when you first learn to add numbers and you don't really know what you're doing with them. You know 2 plus 3 is 5. Well, later you can add 2 apples and 3 apples and get 5 apples. It's the same idea here. New topic, factoring by grouping. When we need to find factors, we can break a quaternomial up into 2 groups and factor each one separately. So what we've got here is a set of 4 terms. We've got w to the third plus 7w squared plus 2w plus 14, and I'm going to groups. Just like that. What I'm now doing is finding the GCF of each group separately. It's kind of like I'm fake finding the GCF. There is no overall GCF. There's nothing that all of these terms can be divided by. Instead, I'm going to break this up into groups. Well, 1 and 7 are only divisible by 1, but the largest number of w's that I can take out of each are 2. So in this parentheses, what's left is w to the third divided by w squared is just w. 7 is 7, and w squared divided by w squared are w to the 0, which is just 1, and 7 times 1 is 7. Before we would have been done. Now we have another set of parentheses. The GCF for 2w and 14 is 2, so I'm dividing both terms by 2. 2w divided by 2 is w, 14 divided by 2 is 7. This should look really similar to the last topic we worked on. Now we have a common factor of w plus 7 that we take out in front, and we're left with what's in front here and what's in front here, which is w squared plus 2. You pause the video and try this one on your own. Same set of steps that I did. All right, you should have started by grouping your first two and grouping your second two. You want to look here. The only number that 1 and 2 are both divisible by is 1, but the largest number of x's that I can take out is x squared. Now we're going to divide and see what's left. 1 divided by 1 is just 1. X to the third divided by x squared is x. Negative 2 divided by 1 is negative 2. X squared divided by x squared gives me x to the 0, which means they cancel out. For these two terms, 5 and 10 are both divisible by 5. They don't both have x's, so that can't be a common factor, so we just use 5 for that one. Now we're going to divide each of these by 5. 5x divided by 5 is 1x. Negative 10 divided by 5 is negative 2. This becomes our common factor now. If they don't match, then you know you've done something wrong and you have to go back. They will match every time you try to factor. What we're left with is x squared from here, or 1x squared, either way you want to write that is fine, plus 5. And that's it. Let's do some of those same ones again, just for a little bit more practice. So if we group the first two, 3u to the third plus 15u squared, and we group the second two, negative u minus 5. Notice I put my negative in the parentheses and put plus in the middle. I always put plus in the middle. It causes me to make fewer negative errors. Think about what 3 and 15 are both divisible by. 3 and 15 are both divisible by 3. That leaves me with u to the third and u to the squared. The highest number of u's that I can take out of both is u squared. That leaves me with u to the 1, because 3 minus 2 is 1, and u squared divided by u squared just gives me 1. 15 divided by 3 gives me 5, so that's u plus 5. Now I want you to notice something. These are close to matching, but not quite. If I take a negative 1 out, what that will do is turn both of these positive, and now they match. So this is now your GCF. You're left with u plus 5 times 3u squared minus 1. All right, you pause the video and see if you can try this one on your own. Remember, group your first two, and then group your second two. Look for your GCF of both. If you haven't been trying these on your own, you need to do that now. Go ahead and pause the video and try these on your own. All right, you should have seen that the GCF for this one is 4x squared. And the GCF for this one, excuse me, let's go ahead and divide. 16 divided by 4 is 4. X to the third divided by x squared is x. 20 divided by 4 is 5. And x squared divided by x squared cancels out. For this one, notice these are both negative, so you should have taken out a negative, and then 28 and 35 are both divisible by 7. They don't share any x's, so we can't take out any x's. Negative 28x divided by negative 7 is 4x, and negative 35 divided by negative 7 is positive 5. What you're left with now is the common 4x plus 5 that we pull out in front, and what's left is 4x squared minus 7. And you're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 10 and ALEKS. You now need to complete Module 10 practice problems in ALEKS by selecting Continue My Path. Don't forget that you'll need to complete Modules 1 through 9 if those have not already been completed. If you need help in ALEKS, don't forget that you can click on the Explanation tab. The Explanation tab will give you an explanation, and then we'll give you a chance to do it that will be the same type. After you complete all the topics in this module, by clicking Continue My Path, you'll need to click your assessment. You'll need to take Quiz 10, and that will go with Module 10. Have a good day.